So this is 7.1, and it's about the areas of parallelograms. Could I have a volunteer read the learning target for us, please? Kaden?
I can find the area and missing dimensions of parallelograms.
Awesome, thanks. And I'm gonna say that word one more time, and then you're gonna say it with me. Parallelogram. Say it with me. Parallelogram. Awesome. Just because I know there's a lot of L's going on in there. So a few definitions. A polygon is a closed figure in a plane that is made up of 3 or more line segments that intersect only at their endpoints. So really a polygon is any 2D shape that is drawn with straight lines. So things like a triangle or a square or a rectangle or a kite or a rhombus. Anything where we just have 3 or more lines that connect to each other to make a fully enclosed shape. And then the area of a polygon is the amount of surface that it covers. So you guys learned in 5th grade and previously, when you have a rectangle, it's like the space inside that rectangle. The space that it covers is its area. Does anybody remember how to find the area of a rectangle before we go into our new area today? Logan? Yeah, because in a rectangle, it's a 4-sided figure. We multiply the length times the width. And today we're going to talk about how to find the area of a parallelogram. We have another formula. So just like how the area of a rectangle is length times width, we have a formula or a rule to find the area of a parallelogram, and that is base times height. So capital A for area equals BH, base times height. Remember, I'm going to write base B times H like that, just in case you're like, wait, what does it mean when the B and the H are touching? It means they're multiplied. In a parallelogram, the base and the height, we need to talk about what those are. The base is any flat side, any side that would be able to sit flat on a table, right? This side here would be able to sit flat on a table. Now, not all parallelograms are drawn with the base at the bottom. So I don't want you to think base automatically means bottom. It just means that flat side that it could sit. It would have a strong base if it sat on that side. Because if I turned it like this side is still the base because that's that side that would be able to sit fully flat on the table. So sometimes you kind of got to rotate it in our mind. The height, however, has to go straight up and down. So the height of a parallelogram is not the slanted edge. It is a measurement that measures the parallelogram top to bottom, straight up and down. Think about if you go to the doctor and they take your height. If you stood like this, they'd be like, what are you doing? That's not your height. That's inaccurate. Height has to be going straight up and down. So that means for a parallelogram, because this side doesn't go straight up and down, our height is either labeled sometimes a line going through it on the inside, like this one, or sometimes it's a line on the outside. But either way, we can see it goes straight up and down from the base. Again, if your parallelogram was drawn like this, we would think, oh, wait, if this is my flat side, my height is going straight up and down from the base. So sometimes turning your paper like this and going, oh, there we go. That might make a little bit more sense. I do want to give you one more trick to remembering where the base and the height are of any figure. Does anybody know what this little symbol means in the corner, that little box? Aubrey? 90 degrees, or does anybody remember the special name for a 90-degree angle? It is 90 degrees, but Natalie? A right angle. So I have a little rhyme for you. A right angle is always right because it shows the base and height. If you find the right angle, the two sides that form it, this one and this one, those are your base and your height. A right angle is always right because it shows the base and height. So we're going to go ahead and just try it out. So this first one, find the area of each parallelogram. Well, I know it's a parallelogram, so I'm going to write down my formula. Area equals base times height. So did I remember what I need to be doing here? Because you're going to learn in our next couple sections that different figures have different formulas. Now I need to figure out what the base and the height are, so I know what numbers to use. Who can tell me what the base of this parallelogram is? How long is the base of this parallelogram? Logan? Because that's like a flat side that we could set on the ground. And what is the height of this parallelogram? Grayson? And we can see how it's going straight up and down through it. 14 isn't the slanted edge, it's the straight up and down measurement. And again, look at that right angle. A right angle is always right because it shows the base and height. So now that I know what the base and height are, I can plug those into my formula. I can say area equals base, which is 12, times height, which is 14. Perfect. Now for this chapter, not all chapters, but for this one, you do get to use a calculator for this. So now all I'm going to do is type this in, and I get my answer. Area equals 168. I need to label it, though, with units, because whenever I'm dealing with anything that's being measured, I should use units. Does anybody remember what's special about labeling units for area? Because I'm not just going to put meters on the end. Swara? One lower, meters squared. Yep. And that's because when I find area, I'm multiplying two measurements. I'm multiplying meters by meters, and meters times meters is meters squared, right? Meters to the power of 2. Another way to think about it is that because area is finding the space that something covers, it's filling it up with little squares. It's not just measuring a straight line, it's actually filling something with squares. So I do want us to add a little note about that up here. Label. Is that how you spell label? Yeah. It's the E before the L, right? Yeah, I think it is. Okay. Label with units squared. And that's for any area, not just the area of a parallelogram, but any area, because we're doing units times units. That gives us units squared, or thinking about covering it with squares. All right. We're going to do our next one. This is, again, a parallelogram. So I'm going to immediately write down the formula that I'm going to use. Area is base times height. And then I'm going to identify what the base and height are. Who can tell me what the base of the parallelogram is? Kaden? Like, how long is the base? 4 feet. And notice that 4 feet is labeled at the top. That's fine. We could think about flipping it upside down, and that side would be able to sit flat on the ground. That can be our base. Base does not have to be at the bottom. If it's easier for you to think about it that way, then flip it around, but it doesn't have to be at the bottom. What's the height of this parallelogram? What is its height? Because I now need that as well. How tall is it? Kavian? 8.5 feet, because we see how it's going straight up and down right there. Also, a right angle is always right because it shows the base and height. This right angle is being formed by this side and this side, which this side is the same as the one across from it. It's also 4 feet and could also be used as the base. So that's another way to identify that base and height. Now that I know what they are, I'm going to plug them into my formula. So I'm going to say area equals my base, which was 4, times my height, which was 8.5. This is a spot where our calculator is not really going to help us because we have a fraction. So a calculator is not going to be super helpful. But we could use a strategy that we learned about 2 chapters ago to figure this out. That strategy is the distributive property, which I know you're going to be like, what the heck? I'm going to imagine multiplying 4 by the 8 as well as by the 1/2 and then just putting it together. And that's going to be easier for me than trying to make 8.5 into an improper fraction and multiply it like that. You totally can do that, but this just might be easier in my opinion. So 4 times 8, that's 32. 4 times 1/2. Does anybody know what 4 times 1/2 is going to be? Emma? 2. So together they make 34. So my area is 34. And then how should I label this answer? Because I'm not done until it's labeled. Erin? Feet squared, exactly. So that's a strategy you can use if you're multiplying a whole number by a mixed number, so that if you want to be able to use the calculator at least a little bit, you can do it that way. If you have 2 mixed numbers, though, you are going to have to make them improper and multiply them. Questions about 1B? All right, last one. Find the area of the parallelogram in square inches. Square inches. I want to point that out. Square inches. What is wrong with the way our parallelogram is currently labeled if my job is to find the area in square inches? What is wrong with this? Neil? Yeah, meaning I need to make them inches before I get started. How do I turn 2 feet into inches? What do I do if I want to know how many inches is in 2 feet? Natalie? So 2 times 12. I'm trying to like fit it in there. That's going to be 24 inches. That means if I want to know what 2.5 feet is, I'm going to do the same thing. I'm going to multiply by 12 as well. And guess what? You can use your calculator. You might already know what that is, which is awesome. But if you don't, type it in. And then we're going to get 30 inches for that one. Okay, awesome. We have done the work of switching over our labels into inches. Now I'm going to go ahead and write down my formula. Area equals base times height. And then I'm going to figure out my base and height and multiply them together. What is the base of this parallelogram? Letitia? It is actually not the 24. It is the 30. Does anybody know why it's the 30 and not the 24? I know that multiplying them either way, you're going to get the same answer, but why specifically is this the base versus this? Logan?
Because the other number goes upwards from that, so that's the base, and the other number is the height.
Yeah, the base is got to be an outside edge. So think about just switching this over like this. Our base is this side, 30 inches, and our height goes straight up and down from that. Also, remember, a right angle is always right because it shows the base and height. This side is also 30 inches. So base and then height is going through it. So our base has to be an outside edge. Our height can go through it or can be like on the an extra measurement on the outside like this one. So base, that means 24 is my height. So area equals base 30 times height 24. Type it in my calculator and I get 720. And then how should I label that answer? What should I label this with for it to be fully correct and proper and complete? Grayson? Inches squared, because we changed it over into inches, and then because it's area, it's that unit inches squared. Questions about example 2?